Ecology and Evolutionary Biology and Mathematics at the University of Tennessee, Knoxville, and founding director of NIMBIOS. He is also the director of the Institute for Environmental Modeling.
Yes.
Good. His research, good. His research focuses on computational mathematical ecology, applications to plant physiological ecology, conservation biology, natural resource management, and landscape ecology. He's co-edited 5 books, including individual-based models and approaches in ecology, which has really been a landmark book to really expand that field. He was the recipient of the 2006 Distinguished Scientist Award from the AIBS and has directed the Society for Mathematical Biology, and recently received an SEC Faculty Achievement Award for Outstanding Teaching and Scholarship.
Go football!
Finally, Nicole Gerardo co-organized this symposium. So thank you, Nicole, and thank you for Nicole is an associate professor of biology. She started the 1st of January 2008, so I know a lot of details about Nicole, because we were hired in the same search by Les. So this was a disease ecology search that hired both of us. She has been the director of the PBE program, is currently director of graduate studies. She is also the director of the undergraduate research for credit program at Emory. Her work focuses on ecology and evolution, mostly of host-symbiont interactions, working on a variety of systems from aphids to scorch bugs. We work together on the microbiome of monarch butterflies. And she has a lot of experience with thinking about graduate education. In 2008, received the Graduate Division in Biological and Biomedical Sciences Faculty Mentor Award for outstanding dedication to and success of mentoring students and postdocs in our lab. So we have a very great panel to really start thinking about what do we really want to, how do we want to educate our students. So I think maybe we'll do the same framework. Maybe we start with Suzanne and we do a few minutes each and then open it up for bigger discussion. Thank you.
So, I'm actually mostly advising students that are in the math department and doing, mathematical ecology or epidemiology, but I would just say that right now I think if you're thinking about students, you want to get students to understand what's underneath their applications. It seems like students are using tools like sensitivity analysis or even optimization, but it's also important to understand what's behind, because when something goes wrong, you need to understand it and how to interpret it. So I think it's good to know some basic analysis, statistics, things that are behind that you understand. So I've definitely been, talking to my students about, learning some statistics, thinking about identification of parameters and reproducibility of models and things like that. Some of the topics that came up today, I think that are important. People are talking about doing optimization. I think it's and optimal control perhaps, but also the whole thing of doing adaptive management, which is management when you get new information or you learn new things that you should adapt. So I think that's an important area. And then the last thing I'd say, it's really important for students to learn to communicate, and that not with each other and then with the public. I think that's extremely important.
So I think I have no answers. I have a lot of questions. So to me, teaching is one of those things where you're constantly trying new things out and you see if they stick, and sometimes they really don't work. And you're constantly learning through teaching. And so I think for me at this point, in terms of thinking about what we should be teaching our students, whether it's ecology or evolutionary biology, is what does an undergraduate need versus what does a graduate student need? And I think Giannis brought up sort of these hey, if the undergrads could lead with these 3 principles, and I agree with that model for undergrads, right? You have this classroom, at least at Emory and probably most of the places we teach, where they're not going to be ecologists, right? But you want them to here's these fundamental principles of life and how things works around you, and one of those is variation, right? And at the graduate level, for me, it gets harder though, because I think there's tools that students need, and Les and I have definitely talked about this. We debated a little bit about this, right? There's this balance of the tools versus the fundamentals. And there's also that balance of, at the graduate level, are you just trying to guide them to learn themselves, or how much should you be teaching? And I don't have any solutions, but I think it's really about sort of thinking about those questions and sort of trying approaches. And honestly, graduate education in the United States is really lagging behind undergraduate education in terms of being innovative and really thinking about what we're doing. At Emory, we teach graduate students, but we don't get any credit for that. It's probably true at a lot of places. And so, really thinking about what graduate students need and sort of how to balance the tools versus the fundamentals is a struggle. And there's not a clear answer to me. Because they shouldn't be taking classes. You'd be like, oh, they should just learn both. But they shouldn't be taking classes for 5 years either.
So first of all, I want to point out that when you look around this room, you don't really see a representative group of folks that are in most of our undergraduate classrooms, and nor even in our graduate classrooms these days. And it's just take a second and think how you came to be who you are.
Bad image.
Yeah. we heard people testify this morning that Les had a big influence on how they came to be who they are.
A positive influence.
Mostly.
The other side.
And yes. So I think we need to be careful about the fact that we are mostly biologists and with a sprinkling of math and other folks in this room, and that there is a whole cadre of people around, including at least one person in the room, who have thought very carefully about research in education and what works in terms of encouraging our students to get concepts and skills and what doesn't work. And one of the great things that I will point out about biology education over the last couple of decades has been an acknowledgement that there is a group of people who know more than we do about what works in education. Active learning was one of the key points, but there's a lot more details about what works. We, as a community, will do better off by listening to our colleagues who have that knowledge and experience and learning from them, just as the ecologists learn from the evolutionary biologists, learn from the ecologists, and hopefully a lot of us wind up in between that we're meshed. And now I want to come back to what Giannis said, okay? Because Giannis gave us a prescription, okay, for 3 things that every undergraduate should know about. And I want you to ask yourself this. So he gave us 3 things. The first was variance, and understanding what variation means and how it differs from the mean. So I want you to raise your hand if you think the undergraduates that you have helped educate recently leave their undergraduate career understanding variance. Raise your hand if you think that that's... All right? The second thing was, notice there weren't very many hands up. Second thing was interactions and the fact that there's context dependency in what we see in the system. So raise your hand if you think your undergraduates get context. Oh, there's a lot more hands there. Okay. And the third thing that Giannis mentioned was exponential growth. So raise your hand if you think your students really leave understanding exponential. Again, not nearly everyone, but so my point is we have an expert who spent his career thinking about what the key ideas are. And these are concepts, they're not skills per se. And we are obviously failing, okay, at least based on that limited set of expectations.
Too much responsibility.
So I'll shut up, otherwise I'll keep talking.
All right, any comments or questions from the room?
You know, so I served on the board for environmental studies and toxicology at NRC for 3 years. And I had to interact with a lot of politicians on the Hill. And what they kept coming back to over and over and over again was the inability of anybody in high-level decision-making positions to understand any concepts of uncertainty. They want facts, they want a number, they don't want any standard deviations, they want to just be told, this is what's going to happen, this is the measure. So it stretches way beyond the failure at our undergraduate level. It percolates all the way up to the highest levels of decision making in this country. This fundamental failure of understanding how to make judgments under uncertainty. It's just a comment.
Yeah, or even that there is such a thing as evidence.
Yeah.
That was not a political comment.
Or that you can ground, eventually you do need to ground policy, or you do need to make a decision even though there is uncertainty. And I think that's the big gap. It's not that you just don't understand uncertainty, but you can't be like, oh, then we just gotta throw it out because we're not certain.
As a statistician, so I can probably say something about uncertainty, because I see a lot of students that are confronted with the problem of understanding uncertainty. And I think the main issue is that students get exposed to this concept very late. Unlike some type of mathematical concepts like algebra or arithmetics, they are exposed since a young age. They come to college without any knowledge about statistics, any knowledge about probability. And a lot of ecology programs or biology programs, they require just one statistics class. And most of the students take it just because it's a required course. So the problem is at the source. Uncertainty, risk, variability are important concepts that guide our decisions, and they should be introduced way before college. They should be part of anybody's curriculum.
So I'll give you a factoid. The fastest growing AP course in the US is statistics.
Right, well, and I'm aware of that. And, but, you know, it's, right now what we are seeing is a generation, a cohort of students that has not been exposed. Also, who is teaching statistics in high school?
Right.
Well, I'd actually like to kind of add a fourth principle to the three principles. In addition to, they all revolve around evidence, but the fourth principle is engagement. If we do not figure out a way to engage students in high school and their teachers, and undergraduate students and graduate students and congressmen and presidents, and why this is important to them, then we've failed in our mission, right? So I think we have to figure out a way to engage all those different levels, and it's not with the same thing, right? It's like, we know the ecological principles, and we know the population and principles, and we know the statistics perhaps it would take two of us to get all those, right? But what we don't know is what engages our population. So we have to know who we're talking to, and what is the case study, or what is the ecological principle, or what is the disease ecology piece that will grab that particular audience, right? So we often think, for example, that our students because they're all pre-med here at Emory, almost there, are not interested in anything that says ecology or anything that says anything except disease. But they really are if you grab them with the things they are interested in. Right? So I think that's one of the things we're missing in all levels of education.
So I do want to bring up maybe something we can discuss, and that is, we just started as a discussion over lunch actually earlier today, and it's when you compare graduate school to when Les was a graduate student to graduate school today. So let's take Les's cohort and the cohort of students today. The way that students were told then, or led to teach themselves, is different from now. So you can correct me if I'm wrong, but it sounds like the way it was done then, you're in an ecology graduate program, you learn ecology. Now you're in an ecology graduate program, and there is ecology, there is skills that we mentioned, but there's also a lot of career advice, workshops, trajectories of how do you do this, CV building, all those things. And I just wanted maybe if you can give some first reactions to this point, and speak to this point a bit, and then get some feedback from the room.
Yeah, I think that, at least in mathematics, only 10% of your PhD students, for example, are going to get a job like you have, right? So, definitely, that's why I mentioned things like communication skills, because I had, like a student recently that just finished and went to a job at the U.S. Department of Justice, and that's quite an unusual thing for sort of a math biology student. So I think basically, to open their eyes and to be, flexible and communicate and and to be able to work into a team. I think that's very important, working in a team. So.
I think it's fundamentally important, but for maybe a different reason than helping them figure out the next step is to, I think there was a long time that we were losing people in STEM fields because they got there and they're like, I can't even tell anybody I don't want to be a professor. Because, you know, and so they were just sort of feeling left out, and then they left, right? They didn't get that PhD, or they didn't get that master's. And the more we can say there's lots of alternatives and we're supportive of that, the more they're gonna stay, right? And they're just as brilliant, they're gonna contribute in a lot of ways. And I think it's just an important part of building up sort of a continuous strength in STEM and new perspective is saying like, hey, whatever direction you go, we want to support you, and you're getting this skill set that's going to be useful everywhere.
I mean, the whole thing about some places is have like, there's only one pathway. And the point is we got to see that there's lots of pathways and try to educate students about different pathways. And even through a graduate program, it seems like sometimes there's only one pathway, a certain set of tests or a certain set of things. And we got to realize if we want to include a wide spectrum of students, maybe there's got to be multiple pathways through the program and multiple pathways where you go. Right?
So I was on a National Academy Committee that produced a report on data science education. And one of the central arguments was against what is often called the pipeline metaphor, where you got students that come in and then you lose some and then you lose some more and so on. And instead a watershed metaphor. And the watershed metaphor says that the students are coming in from multiple backgrounds, multiple perspectives, and they may converge in certain stream paths. We call it multiple routes to success at UT. And the objective is to encourage them all along that way to see that there is a route forward for them. Now, data science as a field, of course, is quite diverse, but ecology and evolution and associated fields of biology are just as diverse. I was just reading a paper in ecological modeling that has this watershed metaphor for all sorts of different modeling approaches to understanding riverine fish. So this is a paper by Yetta Jager and Don DeAngelis. It's a great graphic if you want to grab it and use it. It's sort of a multiple way of doing it. I think the real challenge in both graduate education and undergraduate education is a portfolio analysis one. It is the issue of there's too darn much stuff to know. You're never going to be able to incorporate all of it, either as conceptual ideas or skill ideas, and do it in a single graduate education. So flexibility, as Suzanne mentioned, is really important, okay, in order to have this be effective. But we also ought to think about how we prioritize, and the biology department here is not the same as the ecology and evolution department is at Princeton. And well, I'm not sure which, okay, we're not going to compare. But there are differences in expectations of the faculty about what their students might leave with. So how do you handle this prioritization? Well, one way to do it is you rely on Giannis to come up, or someone who has a lot of experience who says these are the key ideas. Often that's done by looking at some kind of national report, okay? Or you look at accreditation. Now that's not in our field, but pre-meds sort of have a kind of, it's not really accreditation, but some sort of set of ideas like that. Or you could do something, which we're trying to do at Tennessee now, is base it upon what the faculty in the unit would like their students to leave with. And how do you ascertain that? What we've decided to do, and this is for graduate education, and it's all right, honest, it's funded by Burroughs Wellcome Fund. So it's biomedical, that's what they care about. But the same thing would apply for ecology and evolution or any other field. Is that you ask your faculty, give me one recent paper, meaning the last 5 years or so, that you think every graduate from your program should be able to not read with great detail, but at least have a conceptual understanding of the key ideas and the key skills that you need to have in order to kind of understand what's going on. Collect them, and they won't be the same in biology here at at Emory as they would be at Tennessee in microbiology, as they would be at Princeton in ecology and evolution. And then analyze what are the key concepts under it. Now, we tried to do that in a report called the Vision and Change report to some extent. And there's a table in that report that many departments, undergraduate programs around the country have tried to use to sort of sort out the key ideas in their undergraduate program. But the key point here is that there's local differences, and you should exalt those differences. Your departments are not the same as other departments. Why not use that local difference to guide what it is that you conceptually feel is important for your students to know? And so that's in progress right now at Tennessee. I can't say anything about the progress of it. I'll shut up.
So I want to bounce that over to Les, because that means, so let's say with population biology, ecology, and evolution, our graduate program, right? We come together and Yacht picks a paper and you pick a paper and I pick a paper and we all have papers, and then there's this core and we say, okay, this is the core of ideas that all of our graduate students should leave with. Is that a model that you agree with? Or do you think training should be more individualized?
I think it's a model that's very different. And I'm sitting here thinking of what the difference is. And I see this. I mean, Pat Morris-Tower has been lifelong. I don't know whether it's been lifelong for a really long time devoted
I'm older
to it.
than you are.
Yeah, I know. And so she's really focused on this. And we, in our own department, we have people that are really focused on the teaching. What interests me about what you just said is the focus has been on sort of articulating concept domains, skill sets, alternative pathways. 30 or 40 years ago, if you had asked a college like Emory or UT or Michigan or Princeton what the objectives were of an education, it wouldn't have been a list of things. It would have been, well, we want to teach people to be lifelong learners.
Yes.
Now, I'm not sure that we shouldn't go back to lifelong learners, because whatever your concept set is and your skill set is of today, it's not going to be the same in 5 years. So, but what's going to be the same is the necessity to learn what the new concepts are and what the new skills are to be able to do whatever it is you're doing. And just to create the environment in which a spark of inquiry, where our job is to keep blowing on that little ember of inquiry, curiosity, and keep that ember alive. Now, I'm not sure that our whole environment has changed. So undergraduates are under enormous pressure. They aren't driven by curiosity, and they're not really driven by learning. They're driven by the prospects of having to get a job, or their life expectancy is going down in the last 3 years. Their job prospects are going down. I can understand the pressures, but I still think that our fundamental task is to somehow teach people and provide models for people of how we engage in that independent ability to inquire. And I don't really care what you inquire about, but just have that ability. And I do think that our current structure is reducing that daily, that sense of independent inquiry, through the way we fund students, the way we structure classes. Everything about it is driving away from that. So I'm not happy for what I see in undergraduates or graduate students, but I understand it.
I can't even say it strongly enough that I agree so much with Les that what our focus should be is not on picking a set of concepts for now, but on teaching people that they can ask questions and use evidence to find answers to them, because the problems are changing every day. And no matter whether our students are going to be MDs or ecologists or politicians or ditch diggers, they still are going to encounter new questions every day where they can bring the concepts of our discipline to bear in asking questions, if they lead with the idea that they're allowed to ask questions and allowed to find new answers, not just our answers, right? So I would say we need to project what the questions might be for the future and help them see those.
So provoking discourse. And I certainly completely agree. The structure of what we do at most institutions in higher ed in the US is not doing that. And we are the faculty, we are the faculty. You get to decide what to do.
I think if you asked any faculty whether that would be their desire, they would all say yes.
Yeah.
The question is, we're not doing that, and the structures that would promote that are eroding. So the real question is, why is it that we're not able to achieve what it is that we in fact would all like to achieve?
And I think, well, we can all point to societal pressures, as you did, okay? But we can also point to the fact that many institutions do not have what anything like visionary leadership to encourage these sorts of, there's no presidents or in the room, but you know, the leader, just like any corporation, leadership texts can set a tone for what the culture of the institution is. And I believe that there are, I usually point to a couple of institutions around the country in which the leaders of the institutions have made major cultural changes in the institution. I won't say which ones they are because I'm being recorded. but there are some.
Suzanne and Nicole, did you have some final things you want to say before we break up for a group photo?
No, I'm good.
Yeah.
I think overall, I'm just going to say something about Les for a second. That so the first time that we taught graduate course was with Les, and it was nice to see his perspective was very different. I think Jaap and I are super structured, and we come up with a list of concepts and learning objectives and how we're going to do this and how we're going to incorporate teaching R. And Les is like, let's just talk about it. And ultimately, the more we have these kind of discussions, you know, there should be more of that probably at both the graduate and undergraduate level, of just like getting people to really sort of talk about some issue, and having more conversations like this in the classroom, and less about every little learning objective.
Fantastic. Well, thank you all so much.
Thank you.